Alright guys, gonna try and make a video. They're coming on with a bunch of announcements, so sorry if I take a 10-minute pause to listen to it. Sorry again, this is kind of an interesting situation that I only get to see you guys one day so far. Hopefully we come back pretty quick here, who knows though. So we're just gonna go ahead and go with things as we would if we were here. The more difficult lessons, like the applications I told you about Thursday, we're going to go ahead and hold those off until we come back in person. So for today, Wednesday, and tomorrow, Thursday, we're going to be going over 6-1. This is some fundamental important stuff, but I think it's kind of basic, so I think you guys will be A-okay. Any point throughout these lessons, if you want to try a problem, feel free to pause me, or if you need time to get caught up writing notes, I do recommend taking notes. Just like if you were in class, it's important to have things written down. So if you want to pause me and try these bell ringers, this is a review from yesterday or Monday. So pause me. Okay, so let's review. If you're going from degree digits to if you're going from DSM to degree digits, you split it apart, if you recall, you add, and then you divide the minutes by 60 and the seconds by 3,600. So let me get my calculator real quick. So you leave the 20 or 279, and then you add 57 divided by 60. Which, if I can type in my calculator correctly, is 0.95. And then you have 145 divided by 3,600, which is about 0.04. So if you add all that together, you should get, now I'm rounding a little bit, 279.99 about, and that's degrees, okay? So that'd be your answer for the first one. Second one, now we're going backwards. We got decimal degrees and we want to go to degrees, minutes, seconds. Yeah, I definitely switched around the M and an S. I don't know how to type, sorry about that. Now if we have a negative, remember we need to either, what I recommended was to pull out the negative, just leave it out and ignore it till the very end. So that's what I'm going to do. So if we're looking at 183, then we can say plus 0.355. Remember, that's a legal math move. And we want to multiply that by 60, just the decimal. So if you do that, you still have 183. And then 0.355 times 60 gets you 21.3, so we're going to split it apart further, plus 21 plus 0.3, and you want to multiply the decimal again by 60, so we'll do 0.3 times 60, which will get you 18. So your final answer would be 183 degrees, 21 minutes, and 18 seconds. Oh, but we can't forget the negative. You gotta tack the negative on at the end. Okay, so easy enough stuff. Feel free to pause if you need to go over that, see what happens. But I'm gonna go on with the lesson. Let's ignore that for now. So we're gonna talk about angle measures. We talked about standard position and coterminal angles yesterday. So there's going to be a little bit of review for those of you who didn't make it. And then we're going to talk about a new type of measure to measure angles called radian measure. This is going to be brand new, and it gets some time getting used to it, but I think it's easy enough, and I think we'll be okay. So, in angles, just review, consists of two rays with a common vertex. Yesterday we talked about positive angles. It basically goes counterclockwise. So on the left, if you have a positive angle, you go up, so counterclockwise. And on the right, negative angle, instead of going up, you go down, that would be clockwise. So that is review. So I'm going to slide on. So coterminal angles, we talked about this briefly. That's when two angles basically are the same. So for instance, our example yesterday was a 60-degree angle. And to find coterminal angles, you just make revolutions around, so you make a full 360 degrees, and guess what? You have that same angle. Well, basically to find that angle measure, you add 360, so it'd be 60 degrees plus 360 degrees, which is 420 degrees. So 420 degrees and 60 degrees are coterminal. You could also subtract 360. You could keep adding 360. So if you're at 420, add 360 again. So there's infinite amount of coterminal angles with a single angle, because I could just keep making revolutions. There's another one. There's another one. There's another one. Okay. So there's infinite coterminal angles. Now we're going to get back to this with radians in just a second. But a type of example problem we might have today is determining if coterminal angles, or if two angles are coterminal. So if you want to pause me and see if you can figure this one out, go for it. Otherwise, I'm going to go ahead and get started. We know that we can add or subtract 360, and that'll get us a coterminal angle. So all we really have to do is add 360 degrees to negative 70 degrees, okay? And let's see, what does that get us? Negative 70 plus 360 gets you 290 degrees, which obviously does not equal 310 degrees. So maybe another thing you could do is add 360 again. Well, hopefully you guys see if you add 360, we'd be way off the mark. Some problems might require you to add or subtract 360 multiple times, but we cannot add 360 to negative 70 degrees to get 310. So they're not coterminal. So I'm going to give it a big NO and an exclamation point. Okay? So I think that's easy enough. You'll have some of those in your homework. Just add or subtract 360 to see if you can get to where you need to go. If it doesn't work, then they're not coterminal. If you can add or subtract 360, they are coterminal. So, this is a little review. My handwriting is perfect, I know. We're going to reference unit circle a lot this quarter. And basically just a unit circle means the radius is 1. Okay? So if I have a circle, I'm drawing green right here, the radius is just 1. Okay? So if you think about it on an XY graph, which we oftentimes will, oh, that was terrible. This point right here, if it's x comma y, you go over 1 to the right, so it'd be 1, but you don't go up any. 1 comma 0. Here you go up 1, but you don't go left or right any, so it'd be 0 comma 1. This one you go to the left 1, so it'd be negative 1, 0. And this right here would be 0 comma negative 1. Now that'll be important later. Just know that the unit circle has a radius of 1. Well, circumference, if you remember from geometry or even algebra, is 2 pi r, right? Where r is the radius, okay? So, if we're finding the circumference of a unit circle, if we're going all the way around a unit circle, r is 1, correct? Which means that the circumference of the unit circle is 2 pi times 1, which just equals 2 pi, okay? Which is going to be extremely important when we're talking about radians. So, ways to measure angles. The common way you've known is our typical angles, 90, 180, 270, 360. You guys are familiar with that. We call those degrees. So for instance, this angle right here would be a 90-degree angle. Hopefully you guys are familiar with that enough. But the new one we're going to talk about, and it's going to be covered a lot in trig, is radians. Now radians is another way to measure angle length, but it does so by talking about the circumference of a circle. So if you're thinking about a unit circle, one full revolution around, or one circumference around, we said could be 360 degrees. Or on the unit circle, talking about circumference, it's just 2 pi. So 2 pi talks about the circumference of the arc length of that circle, the arc length that's made from that angle, and it's 2 pi. So one full revolution is either 360 degrees, or we can call it 2 pi, okay? And so radians is just another way to talk about angle measure, but it does so by arc length. Now, important thing to note, we're always going to talk about it in terms of the unit circle, so with radius of 1, because if you want to think about it, if I made a bigger circle, okay, if I made a bigger circle right there, not scale, but let's say the radius is 2, well, obviously the arc length for a full 360 would be a little different because it would be 2 times pi times 2, which would be 4 pi, which is an issue. So we're only going to talk about on a unit circle because in reality, it doesn't matter how big the circle is, that angle measure would still be the same, right? Whether it's a big circle or a little circle, we're talking about it in all terms of angle measure. So it's all going to be in terms of 2 pi for the circumference. So I'm going to erase my blue circle here. So an important fact is 2 pi is the same as one full revolution around, which is 360 degrees. So if we divide that by 4, 2 pi divided by 4 equals pi over 2, right? So if you divide 360, well, that's a good 360, by 4, you get 90 degrees, right? So right here, you have a 90-degree angle, or you have pi over 2. That gets you a fourth of the way around the circle. Pi over 2 would tell you the arc length of this unit circle. So it's just another way to talk about the angle measure, okay? And it's called radians. So we're going to be doing that quite a bit this quarter. So if we add pi over 2 to pi over 2, that would get you pi. So pi is a full 180 degrees, okay? And then last but not least, if you add pi over 2 to pi, you have 3 pi over 2. Or you have 270 degrees, 3 times 90 degrees, okay? So again, I can't reiterate this enough. It's just another way to talk about angle measure. And it's just in terms of the measure of the arc length of the unit circle given that angle measure. So if you were asked to find, I don't know, let's say a 150 degree angle, we'll draw it over here. We could talk about it in terms of degrees. It's a 150 degree angle measure. Or another way would be talking about the arc length on a unit circle. So you would find that arc length, which we're going to talk about how to convert in a second. So it's just different ways to talk about it. So, relationship. So 180 degrees equals pi radians. We talked about that. Or 1 radian equals 180 divided by pi. So how to convert degrees to radians, you're going to multiply by pi over 180. And so we usually want to do things in exact answers. So it's going to involve some simplifying. So we don't typically use decimals. There are cases where we do, such as applications, but we're usually going to be doing it in exact answers. And then to convert radians to degrees, we're going to multiply by 180 over pi. So it's easy enough to memorize. There's two small things. Give yourself a second to write these down, and then we'll do a couple of examples. Okay, so 15 degrees. We want to find that in terms of radians, which again is like pi. It's in terms of pi, it's the arc measure length. So, to convert from degrees to radians, if you look back, to convert from degrees to radians, you're going to multiply by pi over 180. Okay? And so we're going to want to simplify. Now, you guys can agree, hopefully, that this right here is the same as 15 over 180 times pi. Well, 15 over 180, we need to simplify. 15 goes into 15 one time. 15 goes into 180 12 times. So this simplifies to 1 pi over 12. So 15 degrees is 1 pi over 12 or just pi over 12 radians. Okay, so that's easy enough converting between the two. So feel free to pause, check again. I'm going to go on with the next one. So let's do 180, or sorry, not 180, 100 degrees. So same thing, we have 100, and we're going to multiply it by pi over 180, which again, we can rewrite as 100 over 180 times pi. Well, let's simplify a little bit. Now, I always like when we got zeros at the end because you can cancel out zeros. So 10 over 18, well, a number goes into both of those, right? 2. So 2 goes into 10 5 times. 2 goes into 18 9 times. And then you still have that pi there on the left. So you get 5 pi over 9. Okay? So 100 degrees is the same as 5 pi over 9 radians. And again, this is all exact answers. I don't think there's any case in this homework assignment where you should have decimals. Tomorrow's lesson, when we have just real basic application problems, you will be allowed to use decimals. Actually, it's probably preferred. But let's try 2 more. But this time we have radians, and we want to convert to degrees. Okay? So, you have 5 pi over 3. And the way I remember it is if you have pi on top, which we do, we want to get rid of pi. And the only way you can get rid of pi is if we have one on the bottom as well. So you must be multiplying by 180 over pi. So this is just simplifying again. If you have a pi on top and a pi on bottom, they cancel. Well, you have 5 times 180 divided by 3. You could either do the 5 times 180 and then divide by 3. Or you could see that 3 goes into both 3 and 180. It goes into 180, what, 60 times? So it just turns into 5 times 60, which is 300 degrees. Okay, so 5 pi over 3 is the same as 300 degrees. Okay, so 5 pi over 3 would be the arc length measure on a unit circle of the arc length that is created from a 300 degree angle. Okay. Oh, I stand corrected. Now 1.2, if we look, we're converting to degrees, so we know we have to multiply by 180 over pi. We're gonna, oh, forgot the pi. Now, we don't have pi's to cancel out. So this is a case where I would be okay with decimals if they don't have pi's to cancel out, like in this case, because you would do 1.2 times 180, and you get 216 over pi. So that would technically be an exact answer. However, that's not really beneficial for us, right? Oh, we have a 216 over pi degree angle measure. That doesn't mean a whole lot to me. Maybe if you're really visual. You can kind of see what the angle measure would be. But I would just, if this is the case where pi's don't cancel out, I would definitely write it in as a decimal. If the homework doesn't specify which place to round to, don't be worried. I definitely won't dock you points for rounding to a different point than I would do. Okay, so this is your homework assignment for today, Wednesday. I believe it's going to be due tomorrow at noon. I'm still trying to figure everything out, so be flexible. I definitely won't make it due sooner than noon. If you have questions, all the odds, all the odds do have answers, so you could use the odds to assist you. I do plan on posting an answer key for you guys. You can feel free to post comments in Google Classroom or email me questions. Another great resource is each other. You guys are all bright and brilliant, cream of the crop, as I told you yesterday. So we're going to get through this. Just hang in there. Also, make sure you don't let this stuff pile up. We do need to contact each other every single day in some way, shape, or form, whether it's turning in an assignment or filling out a Google form for attendance. Speaking of which, there will be a Google form for attendance tomorrow because, we do have an assignment. There will be attendance due today too. I think that's what I plan on doing every day. I'll have a Google form for you guys to fill out. Just check base with you guys. And then it gives you an opportunity to ask any questions, okay? So again, thank you for trying and sticking with this. Good luck. Please email me if you have any questions. And with that, I will see you guys tomorrow.